Hello sir, I am Mohammad Riazuddin from Institute of Aeronautical Engineering, bearing roll number 20955A0408 from ECB section. My concept video topic is Fourier transform of arbitrary signal. Before going to the topic, we'll see what is a Fourier transform. The Fourier transform is a mathematical technique that transforms a function of time domain x of t to a function of frequency x of omega. It is closely related to the Fourier series. Here we will see this the Fourier transform signal s of t and signal s of omega. S of t is nothing but a time domain signal to the frequency domain signal. Cosine wave to the single frequency. Synchronous function is to the uniform band of frequencies. Gaussian is in Gaussian. Double exponential is nothing but Lorentzian. First we consider the standard signal as an in unit impulse signal. Then here if we take a Fourier transform of del of t, unit impulse signal, we know that del of t is equal to 1, t equal to 0, either it will be 0. Taking Fourier transform of del of t during the intervals of integral of minus infinity to infinity, del of t into e to the power of minus j omega t into dt. When t is equal to 0, then only Fourier transform the unit impulse exists. So consider t equal to 0. If t equal to 0, e to the power of t is nothing but e to the power of 0 is nothing but 1. So the resultant should be 1. Del of t of Fourier transform is nothing but 1. Fourier transform of del of t minus t naught is nothing but integral of minus infinity to infinity del of t minus t naught into e to the power of minus j omega t into dt. Here, where if you consider t equal to t naught, according to the unit impulse property, when t e to the power of t as a t naught, we'll get the e to the power of minus j omega t naught. It is nothing but which gives del of t minus t naught is of Fourier transform gives e to the power of minus j omega t naught, and Fourier transform of del of t plus t naught. Here integral of minus infinity to infinity integral del of t plus t naught into e to the power of minus j omega t into dt, where t is equal to minus t naught gives e to the power of j omega t naught. It means del of t plus t naught of Fourier transform gives e to the power of j omega t naught. If we consider the constant amplitude Fourier transform, then take 1 as a constant amplitude, take 1, so x of t is equal to 1. So according to Dirichlet's condition, integral of minus infinity to infinity of x of t into dt should less than infinity. It means it should be a finite value. Integral of minus infinity to infinity 1 into dt is nothing but infinity minus of minus infinity, which is equal to infinity. Means it don't satisfy the Dirichlet's condition. Means it fails. It's not a Fourier transform. You cannot write it as a Fourier transform. But from by going indirect way, from duality property, x of t of Fourier transform gives x of omega. Means x of t is nothing but 2 pi x of minus omega. Del of t of Fourier transform gives 1. 1 of Fourier transform is nothing but 2 pi del of minus omega and 2 pi del of omega. It means when constant if you find Fourier transform for a constant amplitude, the 1 as a constant, then Fourier transform gives 2 pi del of omega. If a as a constant, then a of Fourier transform gives 2 pi a into del of omega. If we consider standard signal as a unit step function, we know that unit step function u of t is equal to 1 if t greater than or equal to 0 and u 0 for t less than 0. But before going to perform the Fourier transform, we have properties that it should be Dirichlet condition should be satisfied. So here this is not absolutely integrable, because u of t, when integral of 0 to infinity e to the power of minus j omega t into dt is equal to infinity, it means it fails to transform. U of t is not generally transformable, but in indirect way, just now we saw the constant amplitude, like that we can do it. Thank you.